Hello students, welcome back to today's class on playing with numbers, and in that we are going to discuss HCF and LCM. In the previous classes we learned what is HCF and we also learned how to factorize a number, but we didn't discuss how to find HCF or LCM using some methods, so that we are going to discuss in today's lecture, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So, as in the last class, when we discussed about HCF, okay, which is the highest common factor, we learned a method called prime factorization, how to find the prime factors of a given number. Using that method, let us try to find HCF of 12, 16 and 28 using prime factorization. Okay, so for the number 12, let me write the tree, factor tree, and also I'll tell you the other method also. Okay, so for number 12, I can write 1 into 12, and the number 12 can be written as 2 into 6. We need to write all the factors such that we get a prime numbers at the end. And for this number 6, we go with 2 into 3. So for the number 12, we can write as 1 into 2 into 1 into 2 into 2 into 3. 1 into 2 into 2 into 3. You can go in this method, or you can simply divide this 12 with all the prime numbers. 2 6, 2 3 times, and 3 ones. So here also 1 into 3 into 2 into 2, you will get the same factors. This is called factor tree. We are trying to bring the factors, right? Okay, the next one we are going to discuss is 16. So 16, if we write the factor tree, we can write it as 1 into 16. That 16 can be written as 2 into 8. 8 can be written as 2 into 4. 4 can be written as 2 into 2. So we can write 16 as 1 into 2 into 2 into 2 into 2. So 1 into 2 into 2 into 2 into 2. Right? In the same way, we have the next number 28. 28, again, here also 16 you can directly divide with 2. 2 8 16, 2 4s are 8, 2 2s are 4, and 2 1s are 2. Right? So 2 into 2 into 2 into 2, you'll get the same answer. Now, let's move for 28. 28 can be written as 1 into 28, 2 into 14, 2 into 7, and that's all. We have all the prime factors here. Okay, so that will give you 1 into 2 into 2 into 7. So we got all the prime factors for this one as well as for this one, number 12, 16 and 28. Now the question is, we need to find all the common factors, and in that we need to discuss the highest common factor. Okay, so what are all the common factors? 2 is a common, 2 is common, as well as 2 is common. Anything more? 1 is also common, but that's okay. Again, 2 is common, 2 is common, 2 is common. Anything more? 3 is here, but 3 is not here, 3 is not here. 2 more? No. 7 is there, but no. These are the only possible common factors. So common factors, you can say they are 2 and 2. So the 2 into 2, the number 4 is the highest common factor of all these numbers. 4 into 3 is 12, 4 into 4 is 16, 4 into 7 is 28. So this is how you can try to find the prime, you can try to find the HCF using prime factorization. Okay, so this method of writing is called factor tree. Okay, or you can simply divide, and also you can try to bring all the factors. Okay, so the next one, find the HCF of 56 and 64 by continued division method. So the method of division which we just discussed, so that is how you try to find, that is called continued division method. Okay, so let's try to write the division for 56, 2 times of 28 if I am not wrong, 2 times of 14, 2 times of 7, and 7 times of 1. Once again, 7 to is 14, 14 to is 28, 22 is 56. Okay, so using this long division method, this is called continued division, or you can say long division. I can write 56 as 1 into 7 into 2 into 2 into 2. And now 64 can also be written as 2 times of 32, 2 times of 16, 2 times of 8, 2 times of 4, 2 times of 2, and 2 times of 1. How many times? 1, 2, 3, 4, 5, 6. Okay, so 64 is 1 into 1, 2, 3, 4, 5, 6. So now tell me how many times this number is being repeated. I mean, which is common between them. Okay, so 2 is common, again 2 is common, and again 2 is common. So 2 into 2 into 2. Right? So 2 into 2 into 2. So that is how the HCF comes. 2 into 2 into 2. So the highest common factor will be the multiplication of all these two, which is 8. This is 8 into 7 and this is 8 into 8. So the highest common factor for both the numbers is 8. So that this is how you try to do with continued division method. Right? The previous one, the factorize, that's a tree method, factor tree method. Okay. So let's try to understand more about these methods. Find the HCF of 10, 35, 40 by prime factorization and continued division. So this one you can try to do that. Okay, using the factor tree, try to bring all the prime factors and here continued division method and see whether you're getting the same answer in both the cases or not. Okay, so that is about HCF. You have more questions. Find the largest number which is a factor of each of the numbers. Largest number which is a factor, largest. Again, that says it is the greatest or the highest. Simply, we need to find highest common factor for all the three. Simple. If it is 2 numbers or 3 numbers, doesn't worry. Just follow the same method and try to write the HCF. Okay. So the next one we're going to discuss. Okay. Now, let's try to understand about multiples, because we need to understand what is LCM, least common multiple. The one we are going to discuss before is HCF and now it is LCM. Highest common factor, least common multiple. So let us try to understand what is a multiple. Okay. A number A is multiple of a number B if B is obtained by multiplying integers to A. Okay. It's very difficult to understand this one. Let us break that into several parts. A number A is a multiple of A. A number A is a multiple of number B. Is a multiple of B if B is obtained by multiplying integers to A. For example, okay, I have a number 24. I can write as 2 into 12. Correct? For the number 12, I am multiplying with 2 to get 24. Correct? So 24 is a multiple of 24 is a multiple of 12. 24 is a multiple of 12. So let me write all the multiples of 12. Let me write all the multiples of multiples into. See, multiplying integers. We need to multiply integers. So 12 into 1 is 12. It is a multiple. 12 into 2, 24 is a multiple. 12 into 3, 36 is a multiple. 12 into 4, 48 is a multiple. So in that way, how many multiples you can write? Infinite multiples. You can write infinite multiples in this sequence. Okay. Every number is a multiple to itself. Every number is multiple to itself. Correct? And every number is multiple of 1. Every number, you can take 57, let us say. It is 1 into 57. So it is a multiple of 1. 1 into some number, 1 into 57 is 57. Correct? You can take any number, 1 into any number. Okay. So 1 into, let us say 10, you get 10. So 1 is a multiple of 10. Right? So now, let's try to understand what is least common multiple. What is least common multiple? When we are discussing about multiples, when we are going for common multiples, C stands for common. Whenever we have common, it is not just for one number, we are having multiple numbers. We are having multiple numbers. So, least number that is divisible by all the given numbers is called least common multiple. least number that is divisible by. This is very important. Okay, for example, I have a very small numbers 4 and 6, let's say. Okay, there is a number 12 which is divided by 4 as well as 6, which is divisible by. 12 is divisible by 4 and 6, correct? Even 24 is there, 48 is there, but out of all these, the least number is 12, which is the least common multiple. 4 into 6 is 12, 6 into 4 is 12. So 12 is a multiple of 4 and 6. 12 is a multiple of 4 and 6. Okay, LCM of 15 and 10. Least common multiple, 15 and 10 means least common multiple. So 15 and 10, I'll write 30, answer as 30. Just tell me whether it is correct or wrong. How? We'll see. There are some methods for that. But how to get that 30? 15 into 2 is 30, correct, and 10 into 3 is 30. Now, I know this is a common multiple. But my question is there any other number which is less than 30, which is a multiple of both the numbers 15 and 10? Is there any number which is less than 30, which is again a multiple of 15 and 10? No. This is the least possible number. This is the least possible number, and that is 30. That is the LCM, least common multiple. Okay. So methods to find LCM, we have division method as well as we have a prime factorization method. We have division method as well as we have prime factorization method. Okay. So now let's try to understand more about this one, LCM by prime factorization method. So let's try to bring all the prime factors. Okay. Find the LCM of 12 and 15 by prime factorization method. So 12, I'll write as 1 into 12. 12 I can write as 2 into 6. 6 I can write as 2 into 3. Right? So 12 we can write 1 into 2 into 2 into 3, and 15 can be written as 1 into 15 and 15 as 3 into 5, and that's it. No other numbers for that. Okay. So 15 is given as 1 into 3 into 5. These are the prime factors. Now the point is how to find the least common multiple. First of all, see which numbers are common for these two. Which factors are common? You can carefully see 3 and 3 are common. So write that number once. Whichever number is common, just write that once. Next, write all the remaining numbers. 2 into 2 into 5. 2 into 2 into 5. 3 2s are 6 into 5 2s are 10. 6 into 10 is 16. So, the least common multiple LCM of 12 and 15 is 16. 12 into 5 is 60 and 15 into 4 is 60. So, 60 is a multiple of 12 and 15. There are more multiples as well, but the least out of that is 12 and 15. Right. Let's move for the next one. Find the LCM of 48, 56 and 70 by prime factorization method. Again, the same method. I am not going to do that. I am leaving that for you. Just take all the prime factors, try to find all the prime factors and see which all common things are there. Just write once and write all the remaining as it is. Okay, so please try to do that. Now, let's try to find the LCM by long division method. How to go with long division method? Let's see here. Find the LCM of 84, 112, 196 by division method. So now, carefully understand, the method is same for any number of numbers. Okay, we have 3 numbers here. The method is same even if you have 4 numbers, even if you have 5 numbers. So, 84, 112 and 196. Let us try to divide all the numbers with one common multiple, one common factor. Let's start with 2 and be sure that we are doing only with prime numbers. Okay, so 270 or 242s are 2, 6, 2, 5, 10 and 1, 2, 56 are 112. 2, 9, 8. Okay, 98s are 196. Once again, we can go with 2. 2 ones, 2 21s, 2 28s, 2 49s. Now carefully observe, we can directly divide with 7. Okay, as all the numbers are multiples of 7, 7 is itself a prime number. 7 threes, 7 fours, and 7 sevens. It is again 7 into 7. Is there any other number? 4. 4 is still not a prime number. Okay, so we'll divide with 2 first of all. 3. Now see here, we cannot divide 3 with 2. So write the same number as it is, but don't try to divide and don't write 3 by 2, 1.5, nothing. Just leave it as it is. That means it is not a factor. So don't divide that. 2 2s, and this also you cannot divide 7 by 2. So it is the same. So I think we can leave it here because all the numbers are prime numbers. So now LCM will be the multiple of all these prime numbers. The product of all these prime numbers, 1, 2, 3, 4. 2 multiplied 4 times into 7 into 7 into we have 1 3 here. All these are prime numbers. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 into 3 48 into 7 sons 49. 16 into 3 is 48 into 49. So how to find this 48 into 49? Let's try to understand. 8 9s are 72, 9 4s are 36, 36 plus 7 43, 9 4s 36, 36 plus 7 is 43, 8 4s are 32, 4 4s 16, 17, 18, 19. Okay, so that becomes 2, 5, 13, 2. So that will give you 2, 3, 5, 2. That will give you 2, 3, 5, 2. Okay, so this is how you can go with the division method and you can find the LCM. You need to bring all the common factors only in prime numbers, not in any other numbers. Okay, so multiplication of all these will give you 2, 3, 5, 2. That will be the LCM of all these numbers. Correct? So let's move forward for the next one. Find the LCM of 102, 119 and 153 by division method. So you can try to do that. I am not going to do that. Just the same method what we have done. So please do that and you will understand the method. You will get the correct answer. Okay, so let's move for the next one. Find the LCM of the same question. Okay, so difference between LCM and HCF. We have discussed what is least common multiple as well as what is the highest common factor. Let's try to have the difference of these two. What is that? LCM is least common multiple. HCF is highest common factor. This is common multiple. This is common factor. Here it is least. Here it is highest. LCM is always greater than or equal to the bigger number. If we have two numbers, let's say, okay, let's say 12 and 24. You try to find the LCM, you will get the answer as 24. It is always greater or equal to the bigger number. Here the bigger number is 24. It is always greater or bigger. Okay, it is always less than or equal to the smaller number. The same thing, 12 and 24, if you find highest common factor, okay, you will get it as 12. It is always less or equal to. Here it is equal. In all the other cases, it is less. For co-prime numbers, LCM is the product. Co-prime numbers, but that means there are no common factors between those two except one. Okay, so for co-prime numbers, LCM is the product. For co-prime numbers, HCF is 1. For co-prime numbers, HCF is 1. Okay, LCM of any integer a and 1 is a. Any number a and 1, LCM is always a, and HCF is always 1. HCF is always 1. Right? So let's try to move ahead to see the relation between HCF, LCM and both the numbers. When we're taking two numbers and we're finding HCF and LCM, let's try to understand what is the relation between these two. The relation here says that LCM into HCF is equal to the product of two numbers A and B. The product of two numbers is equal to the product of LCM and HCF. Product of any two numbers is equal to product of their LCM and HCF. Okay, let's try to take a few examples, verify the relation for 10 and 24. So let's try to understand what is the LCM of 10 and 24 using the division method. Okay, so 2 5s are 10 and 2 12s are 24. Again with 5, let us divide 5 1s and 5 12s, because 12 remain as it is because 5 cannot divide that. Okay, next one, 12 is here, so divide with 2, 2, 1 will remain as it is, 2 1, 2 6, right? And here it is again 2 1 and 2 3s are, and here it is again 3 1 and 1. All these are prime numbers. So 5 2s are 10, 10 2s are 20, 22s are 40, 43s are 120. Once again, LCM will be 2 into 5 into 2 into 2 into 3. So 5 2s are 10, 10 2s are 20, 22s are 40, 43s are 120. That is the LCM. Now let's try to understand the HCF of these two numbers. Okay, so 10, let me write all the prime numbers, prime factorization, 1 into 2 into 5. 1 into 2 into 5, and 24 can be written as 1 into 2 into 3. So there comes 6, and still we have 4 into 2 into 2. 3 to the 6, 6 to the 12, 12 to the 24. So now tell me which factors are common. 1 is common, 2 is common. That's it, right? So HCF is equal to 2. HCF is equal to 2. So now tell me, in these two methods, what is LCM into HCF? In both the cases, what is LCM into HCF? You'll get 120 into 2, which is a 240, and the product of numbers A into B. The product of two numbers 10 and 24, even this is 240. So this is enough to say that the product of numbers is equal to product of HCF and LCM. Alright, so let's move ahead for the next one. That is, if LCM of two numbers is a 216 and the product is 7776, what will be its HCF? A very easy relation. LCM into HCF is equal to product of A and B. What is LCM? 216. What is HCF? We need to find HCF is equal to A into B product is given as 776. So HCF is equal to 7776 by 216. 7776 by 216, right? So now tell me how to cancel maybe 216 tens, 20s, 30. 30 will be near 30. Okay, let me try for 30. What is 30? 0, 0, 0, 6 is 18, 3 1s are 3, 3 2s are, sorry, yeah, 18, 3 1s 3, 4. This will be 4. Okay, and 3 2s are 6. So that becomes 6480, but still we are far ahead. Let me try 216 into 40. That will be greater than that. 216 into 4, 6 4s 24, 4 1s 4 5 6, 4 2s are 8, 8640, 2160, sorry, yeah, 216 into 40 is 8640. So it will be number between 30 and 40. Let me try to find what is 216 into 36. All these are not necessary. You need to cancel 2, then 3, then 4, whatever it is. But I'm trying to bring the direct factor out of that. 6 6 are 36, 6 1 6, 7 8 9, 6 2 are 12, 6 3 are 18, 3 1 3 4, and 3 2 6. So 6, 8 8 16 17, 4 5 6 7, and 7 exactly. So 216 into 36 times is 7776, 7776, right? So that is how you can try to find the numbers or HCF and LCM when one is missing. Okay, so right, so we have one more question that you can try. Product is given as 3276, HCF is 6, find LCM. Straightforward question. Okay, right, we have a couple of more questions. HCF is 6, LCM is 36, one number is 12, find the other. All these are different applications of the same concept, right? I hope you understood all these about numbers. We discussed what is HCF and what is LCM. In the coming classes, we are going to discuss more applications like this on all the topics, right? Thank you so much, friends. Stay tuned to get the next lecture. Thank you.